apparently we're live. Okay. Wow, here we are. I'm going to get started in a few minutes. I just wanted to make sure that I got this live stream working properly. And I wanted to give people an opportunity to kind of get in because I posted that link probably just a few minutes ago. But please help me out with my audio levels because I'm still adjusting things from yesterday. But please help me out if my audio levels are too high or too low or something along those lines. You know, just give me some feedback in terms of like where I'm at quality-wise for those of you that are in the stream right now. Because I can adjust it all right here, which is fantastic because I have a much, much better live streaming setup at home than I do at school, which is just, I love it so much. But I digress. So help me out, give me a comment in the chat. Let me see who's here this morning. So we can get this thing kind of moving a little bit. Oh, create a highlight video. No, I don't want to create a highlight video. Add a stream marker. Ooh, that's interesting. Maybe I will add a stream marker for something, or I don't even know what's going on anymore. Is everyone waking up well this morning? I've been up pretty much since about 2 a.m. just for the fun of it. I don't know. Oh, goodness gracious. There you are. Good morning. Woo, as the people are coming in. I got 4 concurrent viewers out of a class of like 11 or 12. I got 5 now. Yes. Excellent. Again, just as a reminder, because I'm going to get started in about a minute. You haven't missed anything yet, but I'm just asking you guys, what's the quality of my audio and video right now? Like, am I too loud? Am I too what's the opposite of loud? Quiet? You know? 2 a.m. What? Oh, goodness gracious. But yeah, that's kind of where we're at. I'm setting one thing up, and then we're gonna get started with what I want to get started with, and then I'll let you guys know exactly how today is going to run. So no one else is gonna comment. All right, fine. I just wanted to know who else was here, just to be like, oh, hey, good morning. I can't. It's too early for me to turn on a camera, but I can see Mr. Markey in his bow tie on a Tuesday. So I assume it's a little bit too tight this morning. I don't know, but we'll see how it goes. There comes some people. Okay. So here's what I would like to do for this morning, just so we're all on the same page. Obviously, in Google Classroom, you have an assignment due from me later today. It's due by 2 a.m. 2 a.m. I'm sorry, 2 p.m. Again, I haven't woken up yet. I'm still drinking my coffee. Which obviously I would like you guys to focus on. About half of the class has turned it in so far. I'm just taking a peek at that right now as to who's turned it in and who has not turned it in yet. But yes, obviously, about half the class have turned that in. Obviously, I want that done. My goal for today, as the title of this video suggests, is normal distribution wrap-up. What I would like to do is kind of twofold. Number one, I have a short quizzes that I would like you guys to accomplish. I say short because this thing, oh man, I already lost how many questions it was. It's not as many questions as the one we did before, the one that I did the video review for. Then I have some problems that I would like to try on paper with you guys. Well, I say try, but in reality, it's just going to be me doing the problems because when it comes to a live class versus a chat room, the chat room obviously is not synced perfectly with the video, so so I'm going to go over problems based on a PDF that I am going to throw into the stream, and we'll deal with that when the time is appropriate. I'll have to bring my keyboard back up here at some point. And this is all in preparation for, number one, getting done the worksheet that I have assigned in Google Classroom, but also I am going to be assigning you an assessment, a major assessment, to wrap up all of the normal distribution stuff that we have been doing, because we are about to transition out of the stat portion of Prob and Stat and more into the probability portion of Prob and Stat. So I just wanted to make sure we were all on the same page with that. So now check out this transition. Check this out. I can transition to anything using this this setup that I have. Like I can go, hold on, wide shot. There I am in a wide shot. You can see my cat. The cat's trying to hide behind the curtain right there. There he goes. You just saw him. Anyway, I can set up a thing where now on this screen you can actually see a website that I purposefully pick up. So for example, this is the worksheet that we're going to be working on a little bit later. It is similar to the one that you had to do on Google Classroom, but it's not going to include everything on there. Of course, I can switch that over to, boom, to this screen, which is what I really wanted to show you, because this is the information that you will need in regards to joining the quizzes. So I'm going to give you a couple of minutes right now. Open up that quizzes website. Your code is right there. This is kind of like a good morning, welcome to class, let's get our stuff in gear kind of mentality. I want you guys to join that. And obviously, I would like you guys to complete it to the best of your ability. But I'll give you a few minutes to kind of get that together. So go get logged into that quizzes. You 6 people who were in the chat this morning while I drink my coffee. It's a 519116. Where's my volume? Oh, my volume is somewhere else on this thing. I'm on the wrong screen here. Boom, there, that's the screen you want to be on. That's the screen you want to be on. Yeah. Why is this so big right here? Can I make this smaller? Let's make it like that. Move it like that. Maybe if I do that, it's just, it's fine. It's all good. Where are my people joining the quizzes? I heard a noise of someone joining the quizzes. I was very excited about that. Join that quizzes. I'm gonna bring my keyboard back up here just because I gotta log back in. There we go. I hear more pops of people joining that quizzes. I'm gonna have my report window popping up right here. There we go. Haha. Excellent. Close that down right there. Come on, peoples. Be joining that quizzes. I do have to open up this window here. Well, technically, I click start, but if you click start, I think it'll just give you the option of like, it'll give you the option of selecting themes or some junk like that. I don't know. It's a little weird. Hold on, I gotta refresh this window. There we go. I keep hearing like the pops, but it's like, where are the people? But it wasn't showing up. Now it's showing up. There it is. Come on, use peoples. Let's join this thing up. There we go. Okay. Good question. Number one, what we're doing right now is pure practice. This is pure practice. It is a short quizzes. The actual major, I would label as a major when I assign it in Google Classroom. I would actually assign it as a major. Or I would label it as saying it was a major. Now, the assessment, the major that I'm going to do with you guys is not going to be a quizzes this time. It is not going to be a quizzes this time. It is going to be something else that you would have to actually write out some answers for. And I would give you, of course, more time to do it. I would not just give you, hey, here's a major on the day of class, get them done, without any warning whatsoever. I would not do that. So keep that in mind. So, yeah. But this, what you're doing right now, is not the major in question. So, cool. Let's see here now. Boom, boom. All right, I'm going to get started with this in a moment. Like I said, for this one, this is a short one. This is just kind of getting our minds focused on what we need to do. And then I would like to do some review problems with you guys in preparation for what I have planned. So, all right. For whoever else is with us this morning, of course, you can join in. The code will be at the top of the screen. Here we go. It's a short. Here we go. Start. Oh, that's really loud. I gotta lower that. It's really loud on my end. Hold on. There we go. I'm lowering it on my end. Boom, boom. All right, for you guys that are still working, I am going to give you just a couple of minutes, or maybe a minute or so to kind of wrap this up, because I would like to review these questions in particular, the ones that you guys have seen on this quizzes. And the great thing is I can actually bring up these questions on my screen, as is once I kind of end this, which is great. But I'll give you just another minute or so to wrap this up before I click end on this thing. Goodness. All right. Click. There we go. So there might be like a 30-second delay or something in the actual quizzes that you guys have, but I just clicked to end it a moment ago, and I'm going to flip my screen over so that you can see the questions that you guys did. I had to end it just for the sake of time, because I technically only have you guys till 8:20, and my intention was not to keep you the entire time for this particular lesson. So, I got to keep it on this screen. Move that down. There we go. Much better. Click that, click that. That's the window that I need for this. Still getting used to this interface, regardless. So, let's talk about them one at a time. So I'm looking at problem number 1. Actually, you know what? I may end up skipping some of them, but I'll just talk about one. Shape of a normal distribution. It's definitely a bell curve, as you can see right there. It's definitely a bell curve, and you guys clearly did well on that one. The ones that I would prefer to focus on are the ones that are in yellow, but we'll see what happens when we come there. I'm looking at number 2. No, hold on. Let me see. What if I do this? Oh yeah, that totally messed up my screen. That totally messed up my screen. Just need to fix it real quick. Boom. And now it's going to do it again. I hate this thing so much. This is the one thing that Quizzes does not do well, is actually this thing. I need like 2 monitors open. Anyway, so I'm looking at number 2. Number 2, the data is normally distributed. What percent of the data is in the shaded region? This comes down to the empirical rule. I just wanted to take a quick peek as to what you guys picked for that. The empirical rule is basically stating that between +1 and -1 standard deviations lies 68% of the data. That was the 68, 95, 99.7% rule for the empirical rule. Again, some people refer to it as the empirical rule, but that's what the thing does. Number 3, we did fine on. That was, again, the empirical rule, 95% of the data. Number 4, now this is interesting, because again, if you look at the picture for number 4, it only goes from -3 to +3. If it shaded in everything, then it could say 100%, but it only goes from -3 to +3, which is why it's 99.7%. I just wanted to see what you guys all picked on that one. Now, problem number 5, I am going to draw out in a little bit more detail. I am going to draw out number 5 in a little bit more detail. So actually, let me flip over to the top-down perspective right here, so we can see what I'm about to draw here. Okay, so in this problem, a little more of a logical, mathy thing. Knowing the 68, 95, 99.7 rule, knowing that information, I'm just going to put in these little dash marks right here. It's always good to just draw this thing out. So you have a visual reference to it. There we go. All of those wonderful standard deviations floating around right there. And what this thing is saying is, okay, they shaded in everything here, and they shaded in everything here, and they had two little arrows indicating that it would go out forever in each direction. It went beyond the 3 standard deviations. Well, the middle between 1 and -1 standard deviation is 68% of the data. It's 68% of the data. Well, 100% minus 68% would just give you 32%. That's the percent that's filled in right now at the moment. That's utilizing that empirical rule to get that particular thing done. So, yay for all of that fun stuff. Let me flip the camera back over. There we go. Getting the hang of this. Number 6, you guys did very well on. Obviously, same concept for number 6, except it was the outside, well, it wasn't counting the middle 95%. So what was shaded in on the outside was the 5%, as you can see right there. Phenomenal. Number 7. Now, number 7 is very similar. Now, you can look at number 6 and 7 pretty much back to back on this, being that on number 6, those two combined for 5%. Down here, since it's only half of it, that would be 2.5%, as you can see, being the correct answer right there. Interesting. And then number 8, what percentage of the data is in the shaded region? So again, I can actually do this on the picture that I have on the screen right here. If I just flip that over, top down, there we go. On this particular problem, number 8, they wanted to know, I'll put my pen on it, they wanted to know what's the percentage of the area filled in from this portion all the way to the left. Well, if we know what this is right here, which we do, that portion is approximately 16%, because it's half of the 32 that we had earlier. If that portion is 16%, that must mean that everything else all the way to the left is 84%, which is why on that particular problem, if I were to flip that back, there we go, and on that particular problem, you can see right here the answer being 84%. Fun, 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 fun. Click. Number 9. Now, this is interesting. This is something that we hadn't really talked about. We've talked about standard deviation, and we know generally what standard deviation tends to do. Standard deviation tells you how spread out your data is. The larger the standard deviation, the more spread out your data is, the more varied your data is. The smaller the standard deviation, the more consistent that your data is. This question was asking which curve has the greater standard deviation. Well, the one that seemingly is the most spread out looks to me like red. And you can see that there. The black curve is much, 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 much more consistent because all these data points are being like jumbled together. Blue is less consistent, and then red is the least consistent, thus the largest standard deviation. Remember, standard deviation is average deviation from the mean. Number 10, and there were only 11 questions. Number 10, the shelf life of a particular dairy product is normally distributed with a mean of 12 days of standard deviation of 3 days. About what percent of the products last between 12 and 15 days? Now, these are more akin to the problems that you had on that worksheet, the practice worksheet that I assigned you on Google Classroom. I'm going to switch my camera over in a minute, but let me write down some of this information first. They want to know 12 to 15 days. They want to know what percent of the products last between 12 to 15 days. There are technically 2 ways to get this particular problem done. There are 2 ways to get this particular problem done. One way of getting this problem done is being like, well, okay, normal CDF lower limit, upper limit, mean, standard deviation. That's one way of doing the problem, and I can show you that on the calculator that I have here. Although, if you wanted to, you could get an approximate answer using the normal curve and the empirical rule. There's a 12 right in the middle right there. And then 15, 18, 21, because the standard deviation is 3. 9, 6, 3, because the standard deviation is 3. And they just want to know, okay, well, what percent of the data lie between 12 and 15 days? Well, that's half of 68%. Should be 34%. Now, I'll show you on my calculator what it does, because you should be able to see what this thing does on a graphing calculator. This is my fancy TI-84. It still does the same normal CDF. Not like yours. Yours are better. If you did the interface, you do lower limit, upper limit, mean, standard deviation, and spit that thing out, of course, being approximately 34%. If I were to flip over on the quizzes, which I gotta change this screen over, boom, and change this screen over, boom, boom, you can see right there, 34%, approximately. But that's what that thing does. A couple of you did pick 68%, but again, it was about half of that because it was going from the mean up 1 standard deviation. Number 11, the shelf life particular dairy product is the same problem, but they want to know what percent of products, I clicked on it already, what percent of products last 6 days or less. 6 days or less. So it's the same problem, except now they want to know this right here, 6 days or less. It's very similar to everything that we've been doing in some of these previous problems. From here to here, if I kind of extend these lines a little bit, as we've talked about, there's 95% of the data from -2 to +2 standard deviations, meaning 5% of the data is split between these two sides, left side and right side. And if 5% is split, that's 2.5%. Of course, you could always do this on the graphing calculator, where you do some big negative number, comma 6, because that's your lower and upper limit. It's going from some giant negative number up to 6. Comma the mean, comma the standard deviation. Now, it was 2.5% according to the empirical rule. It was 2.3% according to the calculator. Both answers technically would be acceptable, just because using the empirical rule is a perfectly valid way of doing these problems. And you can see right there, 2.5%. Fantastic. Fantastic. Here's what I would like to do. I'm going to flip my camera back here so you can see me. Well, whatever. Anyway, here's what I would like to do to kind of wrap up today. Now, again, just as a reminder, that worksheet is due at 2 o'clock today. That is a practice worksheet. I am assigning you a major, which it's not going to be due right away. It's not going to be due right away. I know it's a holiday weekend, so I want to give you guys a little bit more time to get this particular major done. This major would not be due until early next week. So keep that in mind. I'm thinking end of the day Monday, something like that. But it would be labeled as a major. So please keep that in mind. I would label it specifically as a major so that you would know exactly what it is that is expected of you. But what I would like to do with the time that we have left here is I would like to actually knock out a couple of the problems on the worksheet that I assigned you on Google Classroom. I see 7 in the chat right now. It says concurrent viewers 7 right now. So congratulations. If you're here, then you are actually going to see me do a couple of these problems directly from that homework that you guys did. So if you need to look at it, I'm going to bring up the problems on the screen in a moment. But if you do need to look at it, if you go to Google Classroom, click Classwork, the assignment is Normal Distribution Worksheet. You can see it's due today. Now, again, a bunch of you have already turned it in. Good for you. Fantastic. Absolutely. So now, when I go over these problems, you can see whether or not you did them correctly, which is nice. Just kind of nice. So let me bring that thing up here. Change my screen over. Website to that. To... No, it's not that one. There it is. Nailed it. So let me zoom in a bit here. Boom. So you guys had to do the problems numbers 21 to 30 on this particular worksheet. Now, I am going to pick a couple of problems that I would like to do off of this worksheet. But, of course, if there is a very specific question that you would like to see, please say so in the chat. That would be fantastic. I'll probably only go over a few, and I'm going to pick one to start right now. But if you have one that you're like, ooh, I really, really need to see if I got that one right, or, oh, I had no idea how to do that particular problem, please, please, by all means, tell me in the chat which one you want to do, and we can talk about that. So I am going to start with number 21. And then I do have another one that I have in mind that I'm going to pick, but I may end up picking one that you suggest to me next. But let's start with number 21. In the accompanying diagram, the shaded area represents approximately 95% of the scores on a standardized test. Okay? If these scores ranged from 78 to 92, they want to know what is the mean and what is the standard deviation. Okay, let me write out something here on my little piece of paper, and then I'm going to flip my screen over so that you can see exactly what I'm doing. 78, 92, X is the mean right in the middle. Technically it should be X bar, and they want to know, oh, that's 95% of the data. And that's 95% of the data. Okay, let me flip that screen over. There we go, much better. Nice. So I'm looking at that, and they want to know what is the mean, what is the standard deviation. Well, if that's the center 95% of the data, the mean should be smack dab right in the middle. And obviously, you could probably do a lot of this like directly in your head, but I'm just kind of showing you how you can do this. If you just found the average of 78 and 92, seems silly to do it at that point. I mean, you could just figure that out in your head. It should be 85 right in the middle. The mean for this problem is 85. Now, what about the standard deviation? Now, I told you a long time ago that you would not have to calculate standard deviation in the traditional way of using that formula where you take the deviations and you square them and you add them all up and you divide by n-1 and then you square root the whole thing back. I said, no, you're not going to have to do that. And you still won't. Because for this problem, because they're utilizing the empirical rule of the normal curve, it should be known that they added the standard deviation twice to get the 92, and they subtracted the standard deviation twice to get to 78. So it's like, oh, so 85 plus 2 times whatever the standard deviation is. I mean, I don't know, I'm going to use the letter y to represent the standard deviation. I don't know, I'm just making that up. And it equals 92. Then it just turns into like an algebra problem. So it's like 2y equals 7, y equals 3.5. Yes. They went from 85, and they added 3.5 to get 88.5, and they added 3.5 to get 92. Your standard deviation is 3.5. That's the most straightforward way that you could go about this problem. Absolutely. Steve wants to see 22C. Let's flip over to 22C. Where'd my window go? Oh, just because I minimized it? Hold on, make sure that works. Yep, there it is. He wants to see 22C. Nice. So number 22. It does so that the actual number of bolts is normally distributed with a mean of 106 and a standard deviation of 2. Draw and label the normal curve from the information, as we've done a billion times over and over again. But then 22C, they want to know what percentage of boxes contain more than 110 volts. Nice. Let me get a fresh page here. Where's the other page that I was working on? There it is. It's right there. I'll throw those on the ground. So number 22, again, you could do one of two ways. You could use the normal curve that you drew for this particular problem and utilizing the empirical rule that we have studied. 108, 110, 112. I'm just filling it in right now and keeping the problem on the screen. There we go. And they want to know 110 volts or more. I'm just kind of shading that in right there, and then I'm going to flip my screen back. There we go. So they want to know 110 volts or more. Again, this is 68%. This is 95%. Given that between these 2 points contain 95% of the data, that must mean that 5% are outside those barriers. 5%. But it's 5% that is evenly split between both sides. Logic dictates that this is 2.5%. Another way of looking at it, and again, this is one way of doing it, but another way of doing it is normal CDF. 110, comma, some big number, and I'm going to type that number into my calculator, with the proper mean and the proper standard deviation. And if that was typed in correctly, and I'm going to show you that in just a moment, 110, comma, some big number, whatever that number is, comma, 106, comma, 2. Now, it's not exactly 2.5%. 2.5% was as a result of the empirical rule, but the exact number is actually 2.3%, which is great. I mean, again, either one is acceptable. You do not have to show me both answers. That is not necessary. Show me one of those answers and the work that you did to get those particular things done. That would be fantastic. All right. Now, like I said, I do have another one that I want to try, but again, if you guys do have a suggestion in the chat to go over, I would definitely like to hear what your suggestion is. But I'm kind of flipping through right now. I want to pick the ones, or pick the one or so that I want to do. I definitely want to do one from 23. And I definitely would like to do, oh, that's a good one. I want to do 23G. 23G. And again, if you have one that you want to try, name it in the chat. But let's talk about 23G. I'm going to flip my screen back to the worksheet right here. Boom. 23G. It says the heights of the people of the planet X, whatever, are normally distributed with a mean of 40 and a standard deviation of 5. They are vertically diverse people. Whatever. Don't care. Okay. That's a terrible normal curve that I just drew. You'll see that in a little bit. I'm putting that mean at 40. I'm putting that standard deviation at 5, which means that's 45, 50, 55, 35, 30, 25. That's a terrible drawing. Whatever. 23G wants to know, okay, 84% of Ixians are over how many inches tall? 84% of Ixians are over how many inches tall. Now, I want you to think about this logically for a moment. I'm going to flip it back to my top down because I drew the picture right here for number 23G. This is 23G. They want to know what, or not what percent, but what data point. What data point would be the number of inches tall where 84% of the people are taller than. You want to be thinking about this in terms of percentiles. Actually, there's two ways to go about it, but I'm going to show you both ways. One way to go about it is percentiles. If 84% are taller than you, if 84% of the population is taller than you, that means that you fall in the 16th percentile. It means that you fall in the 16th percentile. Now, if you fall in the 16th percentile, and they are asking you, hey, what's the data point that represents this? This is a job for inverse norm, where I would do 0.16, comma the mean, comma the standard deviation. That would be the order that you would have to type those things in. Now, in your graphing calculators, on your Chromebooks, you have an interface that says area. Area, you would put 0.16, then a mu, then a sigma, which you put 40, and then 5. And then it asks you left, right, and center, or left, center, right, I should say. If you keep it on the left, this calculation will work exactly the way that you want it to. And I'll show you that here. Inverse norm, 0.16, comma 40, comma 5. Now, keep in mind, and everything that I've been saying about normal CDF, everything that I've been saying about inverse norm, normal CDF is where you would put in the data points and it would spit out a percentage. Inverse norm is where you would put in the percentage and it would spit out a data point. That answers the question. If you are approximately 35 inches tall, 84% of the population is taller than you in this scenario. Another way of thinking about it is the empirical rule. That one is sometimes a little trickier because you'd have to figure out, okay, what data point would I have to put it at in order to have 84% on the right side? Like, if I did it from here, that's only 50%. Okay, and then if I added this little bit, well, I know this little bit is 34. Oh yeah, 84%. And then from right here over would be 84%. And from right here, you can see it's 35 inches. That way, using the chart is a little trickier. Using inverse norm is a little bit more intuitive. Now, I want to be very clear because I don't have the following function on my calculator, but you do. If you went to inverse norm and you changed it from left to right, if you changed it to be highlighted on the word right, you could type in 0.84 because then it would basically be trying to calculate, okay, 84% of the population to the right, and it would spit out the same number. I can't do that on my calculator because I don't have that function. You do. I'm just suggesting keep it to the left, have it always be to the left, and then we can kind of interpret it from there. So, okay, and going back to the question, the exact question, the 84% of Ixians are over this many inches tall. That means, okay, 84% to the right. That means that 16% would be to the left. Something like that. Look at part B. I'll do part B, and then I'll take one question from you guys if you have it. But look at part B. 97.5% are over how many inches tall? And then for some reason there's another 97.5%. I don't really get that. Well, if 97.5% are to the right, because it's over that many inches tall, 2.5% would be to the left. And if 2.5% are to the left, inverse norm, 0.025, 45, this would spit out the data point at the 2.5th percentile, meaning 2.5% lie under this data point and 97.5% lie above this data point. 30.2 inches, which, if you know about the 2.5% from the empirical rule, you can see that it's about this data point or less, which is about 30 inches, which would also be acceptable. I'll take another question if you have it. Again, you're going to have to be doing these calculations and writing out, okay, this is how I got the answer, this is how I found the answer, this is what I typed into the calculator kind of situation. I need to see those. I think I even said that here. I would need to know, there it is right there. In terms of work that you used, function in the calculation, I would need to know the function and the specifics that were plugged into them. Due Tuesday, thus this assignment is a little longer than, quote, normal. Hilarious joke. But I digress. Okay. Then here's what I'm going to do. I'm going to talk about one more problem, and then I'm going to sign off for the morning. And reminder, this assignment's due at 2 o'clock today, if you haven't already done it. I mean, if you have done it, good for you, but now perhaps me explaining some things and confirming some answers for you, perhaps you're like, oh crap, maybe I have to go back and redo this. But that's up to you. There will be a major assessment. I will be assigning it probably before the end of the school day today. Yes. And I will label it as a major. Let's see what we got here. Oh, here we go. I could do that one. I could do that one. All right, let's do this one. Number 27. A standardized test with a normal distribution, the mean was 64.3, standard deviation was 5.4. What is the best approximation of the percent of scores that fell between 61.7 and 75.1? Well, let me type something into my calculator, and then I'm going to show you what I typed into my calculator, because I do have to look at the screen in order to type in what I need to type in. All right, flip that over. Boom. For this problem, lower limit 61.6, upper limit 75.1, mean standard deviation approximately 66.8%. Using the empirical rule for this problem would be tricky, simply because the numbers don't line up perfectly. The numbers don't line up perfectly. If I was doing the empirical rule of 68%, okay, well, 61.6, I'm sorry, 64.3 minus 5.4, it doesn't really, I mean, it encompasses 61.6 and then plus 5.4. Well, it doesn't really get to 75.1. I don't really know. You would have to use the normal CDF for that problem because it doesn't fit directly on the dashed lines of the normal distribution. Okay. So, there's about 8 minutes left in the class period, but I'm not going to keep you for this. So, just a couple of reminders again. Get that assignment done. We are wrapping up normal distribution with a major, which I am assigning today. It will be due early next week, so you'll have time to get it done over this holiday break. People are going to be quarantining anyway, so what are you going to do? No one in New Jersey is really traveling. But anyway, if you have any questions, of course, you can email me. Please make sure that you are doing that. Otherwise, you guys have a wonderful morning, and I hope to see more of your parents today. I don't know. I saw a few of your parents yesterday, and I may see a few more of them today. But yeah, I'm going to sign off, and you guys have a good morning. Good night. Or morning, whatever. I don't care.